All right, let's get started. Good afternoon, everyone. Welcome to our webinar. My name is Ben. I'm with the California Lake Management Society, and we really appreciate you joining us today. We have an exciting panel of speakers to talk about technologies that mitigate harmful algal blooms. And so without these sponsors, we couldn't fund our student scholarships and pay for other things that support the California Lake Management Society mission. And so let's give a hand to our sponsors today, SePRO, Oase, and Biosafe Systems. To kick it off today, we will start off with SePRO. We have Wes Bishop, Dr. Wes Bishop, I should say, and Andrea Seelock. Take it away.
All right, thank you, Ben. It says you're presenting. Can you stop?
Oh, right.
Sharing, or do you need to stop sharing? I'll see if I can take control. Oh, perfect. All right. Well, good afternoon, everyone, and sincere thanks for your time today. Let me go ahead and share my screen here. Make sure you guys can see that. Can you guys see that? All right.
Yep.
Yes. All right. Perfect. All right. Thank you. I lost my ability to see you guys. Well, let me jump in and get going, kick us off for the sake of time. But yeah, very excited to be here today. Thank you so much for including us, Ben, in Palm's group. Andrea and I are going to co-present very rapidly. What we're going to cover today is a couple things. I'm going to focus on just a little bit of overview on harmful algal blooms, on cyanobacteria, some of the issues with phosphorus, and really that need for proactive mitigation, and then just highlight briefly our Utrisorb line of technologies. We've worked a lot with this over the past few years. Dr. Byron's helped quite a bit to advance this platform of technologies for more proactive harmful algal bloom control. So gonna briefly jump into that, and then Andrea's gonna wrap it up with a number of our algaecide solutions if you need to control them reactively. So just real quick, we're seeing a lot more of these cyanobacteria blooms spread. They come in all different shapes and sizes. I'm sure you guys have seen many things like this, so I won't spend much time here. But yes, cyanobacteria are bad. They're not good for the ecosystem, certainly not for human health, and we need to address these. They need phosphorus. Again, they have a lot of adaptations to go acquire phosphorus, alkaline phosphatase activity to pull it off of organic matter and go down and find it at deeper depth. So phosphorus is very important to their presence, to their dominance in aquatic systems, and they have a lot of tricks to go after and get it. But I'm not going to dive into all those, but in general, we see with more phosphorus, especially in these more freshwater aquatic systems, we have more algal growth, and a greater percentage of that growth is cyanobacteria. So as you get to these more eutrophic, hypereutrophic concentrations of phosphorus, you're more likely to have cyanobacteria harmful algal blooms, and those dominant in the assemblage. So we really want to bring that down into more moderate levels where we have a nice diversity of more beneficial phytoplankton, support the food chain, and not the potential harmful algal bloom toxin producers. And phosphorus is a big component of that, really ties to this eutrophication process and those nuisance and noxious harmful algal blooms in particular. So just a little background there on why we've focused on phosphorus and how we've designed this Utrisorb platform to help us target and specifically go after and remove phosphorus from these aquatic systems. So acknowledging that phosphorus comes from many different areas. There's different sources of phosphorus, internal legacy phosphorus in the sediment, runoff, inflow, so forth. We've designed different Utrisorb technologies to go after and target these different sources of phosphorus. So Utrisorb filter bags, this is housed inside a mesh. This doesn't end up in the aquatic system. The water flowing in gets captured in this as it flows through this filter material. That's what the F stands for, Utrisorb G. This is our lanthanum modified bentonite, a dispersible granule. It can go through the water column and grab phosphorus, and also create a nice coating on the sediments to inactivate sediment. Phosphorus forms, built up that legacy load down there. Utrisorb WC, this has been one of our lead technologies here. Very efficient in terms of binding phosphorus throughout the water column. This is liquid, it's water soluble, and again, in terms of the amount of phosphorus can be bound to that amount of product, it's one of the most efficient I've ever seen. And then our newest one in the Utrisorb platform, very targeted to the sediment and activation, activated in especially these deep anaerobic nasty types of sediments, Utrisorb SI. And again, Dr. Byron did a lot of the foundational work on that technology. So this is quickly, I'm just going to go through each of these four Utrisorb products very quickly and then hand it over to Andrea. But just wanted to give you that whole snapshot on why we've developed Utrisorb to group bind phosphorus, and then how we've designed each of these individual technologies to target phosphorus in different areas. So again, Utrisorb F, think of these as filter bags, inflows if you have ditches or canals coming in, or stormwater systems flowing in. These are great candidate areas for the Utrisorb filter bags. It is a really cool technology. If you guys have the ability to measure phosphorus, you can pour phosphorus-laden water through some of this material, capture it coming out the bottom, and it takes phosphorus out just that quickly. It was pretty impressive stuff working with it in the laboratory. And we tried all manner of different types of things, and we ended up coming up with a nice blend actually to find some synergy to help us bind it more efficiently. So again, think of this as a phosphorus magnet to intercept it before it gets in the water body itself. Just one example here, a golf course, we put some in. Usually they get all this runoff and a big bloom a couple days after a rain event, but by incorporating some of these Utrisorb filter bags, we're able to offset those blooms. There's a nice article in a golf course magazine there, but we use it a lot to HOA ponds, stormwater ponds, anywhere that has a point source discharge. You can put a filter bag, intercept that phosphorus before it gets in there. That's the best way to do it, so the cyanobacteria can't get to it. Next technology here, again, this is our liquid WC for water column. Liquid, water soluble, very efficient. A little over a gallon of this product combined a pound of elemental phosphorus. Very benign, doesn't mess with pH. Permanently bound for all intents and purposes out there. A very positive ecotox profile, and again, no water use restrictions. So a very efficient product, very easy to do on a routine basis, as phosphorus inevitably just keeps coming in. So as a routine approach, this product is very easy to use, very low use volumes to achieve control. One example here, this was a highly eutrophic zoo pond up in Wisconsin, and got on this Utrisorb WC program now. They've been on it for 3 years and able to really get those phosphorus concentrations much more manageable and under control, and certainly the water quality has greatly improved following those applications. Utrisorb G, this would be our lanthanum modified bentonite technology. We've been working with that chemistry, that type of technology for many years now at SePRO, and developed this Utrisorb G technology to really be more efficient at scrubbing phosphorus both from the water column. It's often put out as a slurry. I'll show you that on the next slide, but then really coating and then activating these available phosphorus forms in the sediment, that legacy load. So there's been a lot of great research on this technology. It's been used, certainly all through California and the US, but again, very benign, no use restrictions. We have a great ecotox profile as well on fish and invertebrates with this Utrisorb G, or this 10% highly loaded lanthanum modified bentonite product. This is what it looks like going out. Some people just put it in the boat prop wash. Some people, work up different systems with the slurry, but this just gives you an overview of sort of what it looks like, how most people put it out. We could put it out dry as well, but really getting this slurry and spreading it out and getting, good coating over the sediments has been really efficient for us. Just, one example here, again, just a farm pond, a lot of eutrophic conditions, incorporating G, and we did some follow-up Utrisorb WC too, as stuff inevitably comes in, but very good results in terms of resetting these systems and keeping nuisance algae under control. And the last technology here, Utrisorb SI, really focused at sediment and activation. And again, kudos to Byron for helping develop this formulation and launch it. But some great studies we've done, really targeted at the sediments and preventing nutrient release from the sediments and shifting those sediment phosphorus forms to those residual or ones that won't become available. Again, much more efficient, only 2.5 gallons here to bind a pound of phosphorus. And works extremely well under many different conditions. little peek behind the scenes, some cool research that's been done here to close it out. So this is what Utrisorb SI looks like at like 400,000x. This is SEM. And we've done some cool X-ray diffraction work at NC State too. They spoke at the last NALMS conference, but yeah, this is sort of what the lanthanum looks like on the Utrisorb SI. And then we also after we treated a water body, we're able to pick out the phosphorus too. And you can see how it lines up. And again, with the X-ray diffraction, we can actually show and prove that we formed the rhabdophane, this lanthanum phosphate mineral. So this was really cool to me. Like, wow, we really grabbed and concentrated right on the lanthanum in this technology. So there's a lot more to that formulation, but I won't get into that today. I'm going to pass it over to Andrea, but real quick recap here. Yeah, harmful algal bloom, cyanobacteria bad. Phosphorus is very important to them. Utrisorb technology is designed to be ecologically benign, but specifically and permanently target and bind phosphorus in different areas in the water body. And with that, I'll let Andrea take over.
All right. Thanks, West. So switching gears slightly to focus a little bit more on algaecide solutions that SePRO offers for managing harmful algae blooms. If you can advance the slide, West. Thank you. So the first I want to talk about is our Captain XTR algaecide. This is a 28.2% chelated copper. This formulation has multiple forms of chelation to really protect that copper molecule for use in harsh water chemistries. But one of the really unique things about it is the surfactant and emulsifier package in the formulation. And what this does through a process we call infusion is it allows more copper to penetrate the algae cell's defenses and get into the algae cell where we want it to work and destroy that cell. This product is registered for use in a wide range of sites, including flowing water. It's used quite extensively in irrigation canals. It is also labeled for chemigation. It has no water use restrictions like irrigation, recreation, or drinking. Again, talking about the infusion technology, the importance to this is that you're able to kill more algae faster with Captain XTR because of this infusion technology. You're getting more copper internalized in the cell where you need it to go to work. And this results in better performance, which equals better control because you're having to treat less often and you're getting longer lasting results. This is an example of a Captain XTR application. This was made at an irrigation district near Southern California. They had a really bad algae bloom happening in December when they usually don't get algae. They called, they said, hey, what do we do? They applied some Captain XTR, and you can see from the picture on the right, they got things back up to where they needed it to be. And this is a golf course, actually in the Pacific Northwest. This course called and said, hey, we've got an event happening in a couple days. We need to get this pond cleared up. And so the applicator came in, applied Captain XTR, and you can see in 24 hours, the picture on the right there, that the algae is gone, and they were able to hold their event, and they were very happy. SeCLEAR. So this is actually a very special algaecide because it isn't just an algaecide, but it's also a water quality enhancer. So you're almost getting two things for the price of one. It is a 4.1% copper, signal word, caution, so minimal PPEs. But the great thing about it is that when you apply SeCLEAR, you're not only controlling algae, but you are also reducing phosphorus. So this allows for improved water quality and clarity, and this algaecide has no irrigation restrictions, and it is NSF certified, which makes it a great choice for use in potable water reservoirs. So you can see in the graph here on the right that after 7 applications of SeCLEAR compared to copper sulfate, we were able to reduce phosphorus by 80% in this water body. This is a great case study for SeCLEAR. This is a potable water reservoir that had cyanobacteria at multiple depths. They had complaints about taste and odor. So they applied SeCLEAR, and you can see just 2 days after the treatment that the reservoir is looking clear of algae, and obviously those taste and odor complaints disappeared. Oxamycin. So this is our liquid non-copper algicide. It is a 26.5% hydrogen peroxide with 4.9% peroxyacetic acid. So this is a higher concentration of peroxide than other available formulas on the market, which means less volume is needed for application, which makes it a really great choice for large volume applications. It also allows for higher use rates, and this formulation provides better stability, efficacy, and knockdown. It does have an NSF certification, so again, a great option for potable water. And we also have a newly updated California label that broadens the application sites and uses available in California. And then lastly, I just wanted to touch on how oxamycin P5 can be used in combination with some of the other algaecides or phosphorus mitigation options that Wes suggested. So for nutrient binding, oxamycin P5 is a great option to oxidize the algae cells. So then they'll release phosphorus, which will then promote for rapid and better binding of phosphorus with our Utrizorb WC, our water column binding product there. And so you can see from the chart on the right that with Utrizorb WC and oxamycin combined, it reduces the phosphorus load quite a bit. And then lastly, oxamycin can be used in conjunction with Captain XTR for really stubborn algae like Lingia. And just a quick little overview of what I've gone through. Our Captain XTR controls tough algae, C-Clear for algicide and water quality enhancement, oxamycin P5, a great non-copper option, also NSF approved, and of course our Utrizorb line for phosphorus pollution. All right, and that's it. Thank you.
Well, thank you so much, Andrea. Thank you, Wes. Up next, we have Greg with Oase. And if there are any questions, either type them in chat or save them towards the end.
Okay. Let me share. Window. This window. Okay. I cannot see anyone. So can someone give me a quick heads up? Maybe let me know that everyone's seeing this okay?
Looks good, man. Good.
All right, excellent. So my name is Greg Wagner. Thanks everyone for allowing me to speak here today. I really appreciate it. I'm the National Sales Manager for the U.S. here and for Oase. And I want to talk a little bit about our lake therapy line of products today. So lake therapy, come on, advance. Okay, that's not working. I cannot make this advance. There we go. All right, so lake therapy, three stools or three legs of the stool for lake therapy: efficient, holistic, and sustainable. We want to be efficient. We want our products to solve multiple problems with less products, each product solving various problems within a water body. Holistic, we want to improve the health. We want to get to the root cause of the problem. We're very much into proactive treatment versus reactive. And sustainable, again, our solutions, we want them to promote long-term environmental balance and benefit both the people and the body of water. So why lake therapy? So the Oase lake therapy solutions are designed to mitigate the effects of changes in the weather and eutrophication in a sustainable, economical, and ecosystem compatible manner. That's not my words. I would say, you know, we want to make a stable, healthy water body that can shrug off upset conditions is how I would say that. Principles of the Oase approach: utilize and enhance natural processes. Our chemistry is all mineral-based. It's a combination of mineral-based chemistry along with biology, again, to enhance those natural processes within a body of water. We want to restore the ability of the body of water to somewhat self-clean itself. And again, like I said, shrug off any kind of upset conditions. We don't want no side effects. Obviously, no one wants any side effects. And we are work very hard to bring a product line that doesn't lead to any bioaccumulation of ingredients. Obviously, avoid disruptions of the ecosystem. We want to, most of all, we want to make your body of water healthier, because a healthy body of water takes a lot less time, energy, and resources to maintain. And, you know, obviously we're looking to integrate these into your management program for your lake or pond. So the HAB strategy, I look at HAB control as risk management, and that comes from my many years. I was an industrial water treatment guy long before I was in the lake and pond industry. And one of the things that we always had to deal with a cooling tower is Legionella. And Legionella is a naturally occurring bacteria. It's everywhere. And the Cooling Tower Institute, kind of the governing body, if you will, could never come out and say, we will 100% guarantee that you do these things and you will never have Legionella. But what they did create was a Legionella risk management, easy for me to say, risk management strategy. And the way I look at that in a lake is, if you got an unhealthy lake, you're at greater risk for HABs. And then so we ask then, what makes a lake unhealthy? And typically it's excess nutrient loading, low oxygen, and excessive organic sediment. That condition generally is referred to as eutrophication. And this is like a big cycle, right? So we tend to start with excessive nutrient loading in a body of water, and that can lead to explosive algae blooms or aquatic weed growth. Now, eventually, the algae and the aquatic weeds are going to die, because everything eventually dies. A lot of times we help that process along with some of the products that we were talking about just a little bit ago. Sometimes it's just natural seasonal changes, but either way, all that is going to die and end up down at your sediment layer. And that can cause you problems, because bacteria are going to do what bacteria do, and that is digest organics. And when they do that, they're going to utilize oxygen. So if we create a low oxygen or anoxic environment at the sediment layer and in your water body, that leads to aquatic life decline. And especially if we get anoxic conditions down at your sediment layer, yeah, we can start to release some of that internally P that is bound up in the sediment. That leads to nutrient loading, which leads to algal blooms, which leads to oxygen depletion, which leads to aquatic life decline. And this just keeps going in a circle and ramping up and getting worse and worse and worse. So what do we try to do to help with that? Well, one of the things that we deal with the lake therapy line of products is we look for this Redfield ratio. The Redfield ratio is a classic concept of what is a healthy, stable system look like. And it looks like 106 carbon atoms to 16 nitrogen atoms to 1 phosphorus atom. That gives you a very healthy, very stable environment in a body of water. Now, as we've talked about, and we'll talk about more going forward, what is usually way out of balance in these bodies of water, especially when you start to get HABs and these issues, is phosphorus, right? That's why we talk so much about phosphorus mitigation. We only need 1 phosphorus atom for the 16 nitrogen and 106 carbon. So we're typically very long on phosphorus in our bodies of water. But our product line is designed to help with this and to balance that ratio out. So again, back to mitigating the risk. Balance the water chemistry, reset your water body. I am a chemist. I have been a chemist my whole life. And so a lot of times I talk to people and I say, chemistry drives biology, right? So if your water chemistry is out of whack, that is typically a very big indicator and a big cause as to why your biology gets completely out of whack. So again, the product line that we have is designed to help with this inorganic carbon. We want to move that up in relation to nitrogen, and our products also help with this nitrogen cycling. and moving ammonia through nitrite into nitrate. And then obviously, as Wes talked about, reducing phosphorus and bioavailable phosphorus. So talk a little bit about how we go about that. So we have two hero products in the line, at least in terms of what we're talking about today. On the left, the Schlix Plus. So, and on the right, SeDox and SeDox Max, now that we have that product out. Schlix Plus, improves oxygen at the sediment layer, helps with balancing the sediment nutrients by binding up a lot of phosphorus. You get bioaugmentation through an enhanced biology that we add with that. And then you get sediment pH buffering. And that's important because bacteria need the correct pH environment in order to work most efficiently. On the other side, on the right side, when you're talking more about phosphorus mitigation, balancing water column and sediment nutrients, we're talking about SeDox and now our SeDox Max product. Much like Schlix Plus, though, SeDox Max, because of the formulation, also helps to improve oxygen in your body of water and also helps with water quality stabilization. So with that in mind, I'm going to talk a little bit about SeDox and SeDox Max first and then go into Schlix Plus. So our first phosphorus binding, major phosphorus binding product that we brought to market was SeDox. And it's got a calcium peroxide active ingredient. And so calcium peroxide will bind phosphorus up by the formation of hydroxyapatite. So it gave long-term continuous phosphorus binding that way. But it also promoted microbial activity by releasing oxygen, which can help with your nitrogen turnover rates and help with your N to P ratio. And it adds some dissolved inorganic carbon in the form of total alkalinity. So it helps with the C to P ratio as well. But in this last year, we saw an opportunity to add a lanthanum component to SeDox. And what that gained us was, instead of 1 pound of P for every 50-pound bag, that bumped our capacity up to 1.5 pounds of P for every 50-pound bag. And again, some of that's through the lanthanum, the additional binding that we got from lanthanum. It also, the two products work synergistically. So when the lanthanum component binds phosphorus, it gives off some hydroxyl ions that helps with the hydroxyapatite formation on the calcium peroxide. So there was some synergy there when we added that to it, and we were able to come up with 1.5 pounds of P for every 50-pound bag. Both products, phosphorus binding, oxygen enrichment, again, adding inorganic carbon, and just helping to balance that nutrient ratio. So again, going back to that whole efficient thing that we talked about, and on the next slide, that's how we feel we're a little bit different in our process for dealing with these situations. Lanthanum bodybide bentonite clay is very well known. It's an excellent phosphorus binder, but it's not going to help improve your nitrogen cycling or adding any dissolved inorganic carbon or increasing DO. Same thing with alum. Again, it's not going to help with this. It's actually going to technically be a net negative in terms of dissolved inorganic carbon, because alum tends to consume alkalinity as it works, and it certainly doesn't do anything to increase DO. So when we talk about our SeDox Max, again, going back to that whole efficient and sustainable thing that I talked about in the very beginning slide, we feel like we've got a product here that can help you multiple different ways and make your body of water healthier. So next product I want to talk about a little bit is Schlix Plus. So Schlix Plus, what Schlix Plus is Schlix is the chemistry portion. It's similar to SeDox, not quite the same, slightly different formulation of some of the same components. And it's designed to get down to the sediment layer, not do as nearly as much work in the water column, get down to that sediment layer and start giving off oxygen at the sediment layer. Plus means that we have added our bacterial package, our BioKick Pro, to that. And our bacterial package is a blend of 7 different bacteria. It's freeze dried, so it reanimates very efficiently. And it's, like I said, 7 different strains of bacteria, a couple nitrifiers, some denitrifier, some carbonaceous bacteria. So kind of an all-star blend to address the types of organics that you find at the sediment layer of a natural body of water. And then the Schlicks, again, is the chemistry, and that chemistry helps enhance everything about the biology in giving off oxygen. Again, it provides some pH buffering at that sediment layer so that the environment is ideal for the bacteria to go to work and digest those organics. And because, again, the main active ingredient is calcium peroxide, we get that phosphorus binding via the formation of hydroxyapatite. So again, another efficient thing, doing several different mechanisms in order to make your body of water healthier. So why should I use Schlicks Plus? It's a slide we like to look at. So on the right, we have Schlicks Plus. In order to get all of the benefits that one would get from Schlicks Plus, you'd have to look at some aeration. You'd have to look at adding a nutrient binder. You'd have to look at bioaugmentation. And then truly to match it, you would have to put some form of pH stabilization into the water. All of these things on the left side to get the benefits that you get from one application of our Schlicks Plus product. Implementation strategies of CDOX Max. And again, I know I'm talking to a lot of folks that are talking about HABs and bodies of water. So, option 1 is a complete lake reset. Add enough product to account for all the phosphorus that you have in that body of water. And you'll get significant mitigation at one time, but you also get a very significant one-time cost. Option 2 is annual treatments, typically larger doses on an annual basis. You can spread those costs out over years. One of the things that Wes talked a lot about, after 2 years, 3 years, all of this is a process. Typically, these ponds have aged out. So getting all of that resolved in one application is typically not for the best. So if you spread those treatments out over 2, 3, 4 years and chip away at your problem year over year, you tend to have, 1, from a financial standpoint, that's easier to swallow, but 2, you tend to have longer lasting benefits from that. Option 3 is maintenance treatments, very small, like once a month treatments. That's more for smaller ponds, maybe HOA ponds or small personal bodies of water. And that can work very well as well, but that's typically on your smaller bodies of water.
Hey, Greg, you're up on time. Do you want to quickly just wrap up?
Yeah, absolutely. Schlicks Plus, we can do that as well. Again, whether we do a big dose, small dose, that's something that we can discuss. We've had lots of impacts. We like to talk about investing up front. So doing a treatment up front to get you long-term results. Again, talking about this risk management by getting better water and better results. We have an entire product line. We can do more than just the things I talked about today, up to and including some subsurface aeration. So I want to just thank everyone for letting me speak. Sorry I went a little bit long. And last slide here. Thank you. And there's my contact information and a link to our website if you'd like to get a little bit more.
All right, great. Thank you so much. Also, with SePRO, if you want to share your contact information in the chat, that way people can reach out to you if they have any questions. Moving on, we have Thomas Warmuth with Biosafe Systems. And just got a question. So will the slides be shared with attendees? They can be. If you want specific slides, you can email the presenters. Otherwise, this meeting is recorded. So just keep an eye out and we'll send out a link for today's recording. In that note, we also have last week's recording uploaded, and so we'll send an email with a link to that if you're interested in watching that. All right, so without further ado, we'll take it with Tom.
Good afternoon, everybody. I'm going to see how I get this off of my screen so I can see my own presentation slide. All right. Thank you again for the opportunity to come and talk to you all. And 15 minutes goes by quickly. I have several slides. I'm going to discuss our chemistries and essentially give some case study and background on several places where we've used this and implemented these control methods alongside other programs that are existing. And I like, everyone's discussing holistic approaches, Greg, and I think that is important is, using all the tools in the toolbox to, get to an endpoint for healthy water bodies. We are the OG in, manufacturing of chemistries of peroxygen chemistries like PAA. We are a manufacturer of it uniquely in this market. We make PAA and peroxide products for a lot of water treatment, specifically for obviously algae control, but not only for lakes and ponds, but in horticulture, agriculture, and human health, sanitization and disinfection, wastewater, effluent disinfection. It's always, treating for pathogens in water, as well as with the granular products used across the very broad label on that label, used in nurseries, greenhouses, in and out of water. But anyway, these are obviously copper alternative chemistries. Green Liquid 5.0, which has a higher amount of PAA, which is important in these chemistries. If it was just peroxide, as far as an active ingredient being more important, we would just use peroxide. PAA is the key factor in controlling of the more difficult gram-negative pathogenic types of bacteria, similar to true bacteria like cyanobacteria. These chemistries are, OMRI certified in our market for use in a lot of, like I said, farming, source water for any organic uses. We do a lot of leafy greens down south in Yuma. We do a lot of almonds and things in California as well, up and down the coast and then across the country. But NSF and ANSI standard for drinking water as well. These chemistries are interesting in that they're selective versus copper, is being selected to treat at these therapeutic rates for cyanobacteria and not having impacts on your beneficial phytoplankton, which doesn't impact your entire community up the food chain. You want to have good green algal phytoplankton in there, as well as promoting that species diversity of phytoplankton and keeping that water alive is what also buffers those changes. You release those nutrients from a control with these peroxygen chemistries. The phytoplankton can take in those nutrients, and you're not clarifying the water column to the point where you have resurgent growth from benthic species several feet below after, let's say, a copper treatment on the surface. So I'll get into some of these case studies, and then what's the difference between green algae and cyanobacteria, and why you get these difference in selectivity and control is they're built differently. You have a cell wall and you have a membrane versus algae versus cyanobacteria. Algae can handle, like in the picture here, the guy's got his protective Lederhosen on and he can handle his peroxide, or in this case beer, because he's got the protection of the cell wall. He's got the genetics to handle a little bit of, in this case, beer or alcohol. Cyanobacteria has neither of those things. It cannot handle low levels of peroxide, being taken in by the cell. It does not have the membrane-bound organelles or cell wall. So they end up having, issues with, handling the peroxide, as well as being oxidized and controlled by these chemistries. And you see that across the board in these, pre and post applications where you still have existing phytoplankton, green phytoplankton. So liquid PA peroxide is typically used in season for lake depth, in the water. Can also be used for shoreline floating mats and nuisance algae along the shoreline. But typically, this is what we're using for HABs control. Granular product has been out for a long time, 30 years or so. It's been in many different forms and labels. They're all pretty much similar in the chemistry. It's sodium carbonate peroxyhydrate, PAC 27, phycomycin, and Green Clean Pro. Again, our label is vastly different, as that it can be used in and out of the lake on a lot of things, including boats, boat ramps, docks, you name it, any unabated surface. But it also can be used. It has been used in blanket applications across water bodies. It's lower in efficacy because it can miss your water column where you're trying to target it. It's hard to spread. It's not the same activity. It's only a peroxide that comes off of this granular form. There is no PAA, so it's limited in that aspect. It's really more of a contact algicide. And one of the other applications we've been, researching for years with Army Corps and in practice for about a decade in the Northeast and other places is using it in cooler water to treat overwintering cyanobacteria. And I will touch on that in a little bit. That's what these guys here are doing up in Connecticut on a drinking water reservoir. It's actually applying it in the early season while the water's still cool, letting the material sink, which it does in cooler water. Instead of activating in the top meter or so, it sinks to the bottom, slowly reacts in the cooler water, and then targets that sediment layer of dust of overwintering cells. Uniquely too with peroxide chemistry, this is with the Green Clean Liquid 5. Some old research from 2017 that we did is looking at microcystin degradation that's free in the water, and with this is one of them that was just a free microcystin toxin in the water versus a control, and degrading the toxin that is available in the water post treatment, what's already in the water. And then another trial was intracellular, getting extracellular by the lysing of the cells. So you can actually see over the course of minutes, really, neutralization, essentially oxidizing of those toxins. And this is looking at even 10% of our label up to 100%, just rapid degradation. And we can talk more about that. I just want to get through some of these slides. But into the first example, this is I'm up in New Jersey right now. I'm meeting with these guys tomorrow. Planning next year's applications. We've moved through several of their, starting off with one reservoir, moving into the second and third in the line of chain of lakes here, getting them off of an acidified copper algicide. And ultimately is because they needed the selective control. Early treatments and then continued treatments throughout the season was leading to just 6 to 8 treatments of copper throughout the year. They were clearing up the water, cyanobacteria would come back, and it would come up from the bottom of the lake. They have aeration, so it's the aeration is bringing these cells off the bottom of the lake, starting this in the spring. And once they treat the first time with copper, there's no green phytoplankton, there's no zooplankton, the diatoms are out. You don't see Daphnia, so there's nothing there to buffer that release of the nutrients again. And the light comes back to the bottom of the lake. More cyanobacteria get reintroduced without any competition. And what we're seeing over and over again is the selective control, allowing for phytoplankton to be that buffer in long-term control methods. So great, and interesting here as well is in this particular reservoir, this is the second reservoir in the chain of lakes that was done this last year for the first time after the success of the first one. They're now doing 3. Is they're not treating the entire reservoir. They're treating, like those 2 yellow patches are the treatment sites. So they're treating partial zones of this lake and still getting full lake control enough that they have clean drinking water, geosmin levels going from 100 parts per trillion down to less than detectable, under 10, and toxin levels going from 0.5 to 1 part per billion. Not too high, but something that I don't even want to have to deal with and filter out later. But great reservoir management here. Just a map showing them, but a lot of data being collected here. Some of the more simple stuff is pre and post treatment, that dotted line. The inversion of the chlorophyll versus phycocyanin. You got the blue-green algal pigments pre and post inverting. You're having more chlorophyll post treatment and throughout the season. Essentially controlling the cyanobacteria and promoting of the beneficial greens throughout the season. In addition, they're also using satellite detection to look over and see the verification, ground truthing of their the data of the cell enumerations, as well as their chlorophyll and phycocyanin counts, and then looking over time, geosmin and microcystin dropping pre and post treatment. And most importantly, they're using a line running system of a probe from YSI. Each one of these separate columns is a site that was being tested at depth from the surface and down, pre and post treatment. So these are, I think, 1, 2, 3, 4 days in a row. So that first section is the one whole series across the lake. Post treatment, red being high levels, risk levels of cyanobacteria, and then at depth going down to about 3.5 meters of the depth of the lake. Post treatment, turning blue, and following that throughout the season. They went from treating 6 to 8 times throughout the season, starting their treatments in June, ending in September or October. 6 to 8 treatments with copper, moving to only 2 treatments. This has been consistent now for 3 years, only 2 treatments using Green Clean, starting in June, and then typically having a second treatment sometime August, September. And then this is the 2 years of data on one of the reservoirs here, just showing, pre and post treatments. It seems to be cumulatively getting better as well as they're improving. They're implementing other things, holistic approaches. There is using biochar and some of the water runoff from stormwater, as well as a few other things, improving their aeration systems. But I do have something I can share later if you want to contact me. And I'm going to eventually have it on LinkedIn so you can download the PDF of the white paper that they observed, excellent increase in non-target organisms, 60% increase in essentially their phytoplankton community. But it translates over. This is a potable water reservoir, yes, but in general lake management, this translates to better water quality overall. And the proof's in the pudding, I like to say, with the what's happening inside the plant. These guys are producing drinking water and selling it to the community, right? But because the water is cleaner, the phytoplankton community and the water quality is better coming into the plant. And yes, they have green algae. It's not gin clear water, but the cyanobacteria is controlled. The source of the geosmin is controlled. Toxin levels are controlled. But the green phytoplankton and the diatoms and the zooplankton, everything in there is filtering out and alive still and lowering pressure on the plant. They've reduced their activated carbon by 80% year over year, and that's been consistent now on 2 different reservoirs. And so that's what they're using to filter out all this junk. Previously, the plant would have to deal with about a week of what they call the death cloud rolling in every copper treatment. They'd have a week of all this material getting sucked into the plant of dead algae, which would clog up filters. Taste and odor would go up. Use of all these products to clean the water would go up, and that's all changed. So they're saving a lot on labor and in other chemicals through this application. Next, I'm going to talk about the overwintering cell, and I'm just showing slides from these are Nalm's presentations. These aren't even my presentations here at this point. So Dr. Skira Kinley-Baird, previously a student under Doc Rogers of Clemson, as well as Alyssa Calamini and Andrew McQueen, also from Clemson, PhD students. But the rest of the folks here are from either Aquatic Control, where Sierra Kinley is now, the Army Corps of Engineers, where Alyssa and Andrew are now. Grace Bichette is with Aquatic Control, and the rest of the folks there are either with the Army Corps or Kansas Department of Health. So here, again, not to dwell on it, but you have overwintering cells. The cells, overwinter at the bottom for many of these problematic species. Water temperatures go up, light attenuation increases. They come off the bottom, essentially germinate off the bottom. The echinites as well, around 60 degrees, 13.5 degrees centigrade, 60 degrees Fahrenheit. They get into the water column, and we don't really see them until they're a problem, until they're a harmful algal bloom at the surface. And once they get to the surface, they're becoming more autotrophic. They're using the sun's energy. They are also pulling in the nutrients that are available. They're competing for light. Now you have these scums, right? The question was, could you use the granular in this cooler time of the year, right as the water temperature is hitting that 60-degree mark on the benthos, and allowing the granular to go down there and delay the onset of a HAB, or at least decrease the severity? And it's pointing to, yes, there are some definite signs that that's working. I know there's some people in this room that have used this application method and has seen some dramatic results as well. If anyone wants to chime at the end, they may. Essentially, it's a 100-acre lake or so. It's uniquely, it's kind of like a bow tie. It's pinched in the middle, which allowed us to have a treatment side and a control side, and essentially separating the 2 water bodies with a turbidity curtain that went down to the bottom of this little channel that connected the 2 to keep the water and essentially the cyanobacteria from not mixing as much, but at least along that interface. Really high levels of cyanobacterial content here. Even in the winter, the lake was still fairly green. Early season, starting like February, March. The bottom of the lake would look like green, like a pool table or a poker table. It was just green with the essentially the sedimented cells that are just down there hanging out until it warms up. The method here was using the granular at max rate for the bottom 2 feet. So essentially they're using 100 pounds to acre foot max rate, bottom 2 feet, so roughly 200 pounds to the surface acre, applying that most of that material gets down to the bottom of the lake and onto the benthos. In this case, due to it was determined that there was such a high cell count and the amount of cells on the bottom, they were taking advantage of the labeling of the Green Clean Pro that allows for it to be used every 48 hours. So they did 2 treatments, 48 hours apart. Second treatment, not as much, was at 77 pounds an acre foot, and put out with blower and slurry systems. But overall, this is the average throughout the entire year, the average cell density for the entire growing season. So pre and post, the treated side being blue, the control zone being green, a high p-value on, and I'll say why in a minute, of that treatment zone. If I go back, if you notice here that the red side, our treatment side, up to the north, you see those lakes. Those are ponds that are for the fishery for the state of Kansas. They were not supposed to be discharging anything into the lake during the season, but they had an emergency where a cyanobacteria bloom was in their tanks and in their ponds, and they flushed it into the treatment zone, which temporarily bumped up the cell counts pretty high, but it kind of buffered out quickly over the course of a few weeks, and just general cyanobacteria wasn't really problematic species. And this was all being measured in just phycocyanin levels or the pigment levels, so there wasn't a lot of enumeration being done The problem species was Microcystis for the most part in this lake overall. But if you look at the breakdown, and in this case, that red line is not the treatment. The treatment was done at the beginning of this graph chart in late April. And this was when that discharge happened from the facility. So it spiked up. You can see there's a break in the y-axis. It was actually quite higher than what you can see here, but relatively jumped back down in both sides of the treated and untreated zone quickly in July. So you could say the untreated zone there throughout the rest of the season was significantly higher than the treatment zone, which in this case, the treatment zone has the higher level of nitrogen or phosphorus in the sediment. I think 4 times the phosphorus is in the sediment there. I could get to, again, the papers from this because it just had more discharge from that fish hatchery consistently throughout the years. It's also the primary side where the water comes in. It just has more sediment and nutrients overall. But this, again, proofs in the pudding in this case. Again, this photo was taken 5 weeks prior to the initial application. This is in a downpour of a storm right now. You can tell there's some water droplets, but on the control side, the untreated zone, very high in cell counts. The scumming there is visible. Treatment zone, pretty clear up and through 5 to 8 weeks later. And overall was fairly cleaner throughout just with that one treatment starting in the beginning of the season. All right, so next I will go into a similar application using the granular again for kind of a prophylactic approach, treating the bottom of another drinking water reservoir here, and then following it up with Phoslock to bind up the free reactive phosphorus. So the Phoslock, again, the OG lanthanum modified clay, utilizing it post-treatment, we call it shock and lock. The limnologists hate the shock sound, sometimes like you're treating a pool, but it rhymes with lock, so we like to say that. So what we're doing here is not only just looking at the treatment and pre and post, but also the importance of like monitoring, and if you have the ability to have a live monitoring of your water quality, of cell or of the pigments that are there for cyanobacteria, as well as the green algae, to monitor both of those populations, along with many of your other water quality parameters. You can predict what's going to be coming up. Like if you see that your aeration system went down, you could figure you're probably going to have a phosphorus release. If the DO drops down below and your pH gets messed up, you start seeing phosphorus releasing off the sediment. If temperatures are getting to the point where you know you're going to see the cyanobacteria coming off the bottom of the lake, you're going to know that it's not in the water column. A lot of things can be done. Specifically here, the site's about 30 acres. We started with the mapping with Biobase. We were using Lake Tech here for the platform to monitor these probes at the surface, the middle, and at the bottom of the lake, which is approximately 30 feet deep. In this case here, SePRO was doing some of the wet chemistry for Amaruk Environmental, and the monitoring again by Lake Tech. I won't get into it's not that important to talk about the type of probes here. Again, this was from Nalm's presentation earlier. This is the benthic mapping. Again, also important is kind of know your sediments, the hardness of the sediments, where your pockets are, what's the depth, what's the true volume of the lake, using mapping from Biobase. But yeah, following through, trying to get that water, the water and sediment nutrient load controlled with the Phoslock after the treatment. And that picture down there is actually the treatment day. Well, this was one month after treatment. At the beginning of this is the treatment day with the Green Clean Pro. This is a pretty nice looking lake. You wouldn't think you were treating a lake this time of year in that type of condition. But again, we're trying to target the bottom before the lake looks like junk. This is the application of the Phoslock. Similar application here as the granular was either applied with a vortex blower or in a slurry system, spraying it out over the top.
Hey, Tom,
again,
we're just about out of time. Do you mind wrapping it up?
Sure. Let me get it to the last one. Essentially, again, we saw improved with just Green Clean the first year, improvement of the overall water body. It did not need to go into shutdown and start pumping well water in that cost $1 million a month. Previous years, they had to do that. Following year, when they started using the Phoslock and they split their treatment into 2 years, instead of seeing an eventual ramping up throughout the season, following it the next year with using the Phoslock, essentially flatlined. As you can see the Green Clean and then the Phoslock applications, they never saw the cyanobacteria pop whatsoever out of this lake. So program goals moving into this year, this treatment, again, Phoslock's already been applied for the last 2 years. It'll just be Green Clean again. Lastly, for an example from California, there are several, and there's some from several years ago. I could talk about um, uh, the lakes over there for San Francisco Public Utilities and a few others. But this is more recent, is Lake Elsinore, what they used to call Lake Smelsomore. 4,000 acre lake, receives a lot, $6 million gallons a day of reclaimed water. It all evaporates, condenses, lots of nutrients, lots of loading. So, you know, what we're looking at here is essentially treating the hot spots of this large lake. The whole lake's not being treated, but there's a lot of areas where the windblown scums are very intense. The company here, American Lady Vet's doing the applications down there. Long history of HABs. They're also using some oleander systems, some of the largest ones that they have available, as well as Phoslux. Again, multi approach here of using lots of holistic methods. But what's interesting here, I think the liquid peroxide, the Green Clean Liquid 5.0 is really the one of the factors of keeping these hot zones under control. Essentially, about monthly treatments to try to keep the scums down. What they do well there is they do some regular sampling for testing of free toxins, microcystin toxins. And this is the 2 years up until the end of this last year of the monitoring. The first treatments started in June, right after that red bar. That was the kind of peak season of of where they went and initialized their treatments. And then post that, they got out of just in the caution zone, even into the late part of the season. Again, you get into the winter, you wouldn't expect to see that, to see many, of the warning danger advisories. But moving into the next year, they're at non-detect starting off right away, because they were, applying the granular along shoreline areas and then starting the treatments before they were seeing the bloom conditions. So throughout, again, holistic approach, you had better overall water quality there following these peroxide treatments, and then and even with the Moliere system, still wait to date to see some real data out of that. But this is my contact information. I'd love if you contacted me. I can get you that white paper from Veolia. Again, I think that's some really good information and data on that, as well as anything backing the granular applications and overwintering control. And really, because of the differences in these chemistries, specifically, your site and what type of control, what the goals are, is what product to use, when to use it, why you would use one over the other. Please contact me. I'll let you know.
All right. Thank you so much, Thomas. Well, we're going to get to our Q&A part of this webinar. So if there are any questions, I will open the floor.
I don't have a question, but I'm going to speak on the overwintering of the microcystis with the Green Clean Flow. I had a community where I used it last year, and we had a 90% reduction in a microcystis. So I will vouch for how well that Green Clean worked for the sediment treatments.
That's very notable. I appreciate that, Doug. Yeah, that was just a single application, early season.
It was early season. I did 2 doses at max label rate.
For the 1 foot. So 100 pounds, 100
Yes.
pounds to the surface acre, 100 pounds per surface acre, not acre foot. Okay, right. Yeah, essentially you're applying to the surface, and that 100 pounds, 1 to 200 pounds is going to the bottom. And with the difference in sizes of the prill, most of it gets down there, some of it dissolves on its way down. But yeah, that's that target zone. And you used less than they used at the other sites for Army Corps, but you still saw results. Application is also important. I know we spoke a while back, but you were hand spreading it and still saw good results. Ideally, consistent spreading it over the surface is what you need, so you get it to the bottom, just like any other most of your granular products. But
I have a question. Roughly, what is the cost of this per 10 acres of a lake?
So talk about your question. Like, are you interested in a specific product?
Well, I came in a little late, and I think you were talking about applications of to kill harmful algae, the cyano, and I was interested in what the application of that might cost for a lake roughly the size of 40 acres.
Okay. Well, let me phrase it in a way for everyone to answer. So obviously lake communities and algal assemblages, it's going to depend on, it's going to determine your dose. So it depends on the current conditions, but let's just assume a 40-acre lake with moderate severity bloom. SePRO, what would you kind of estimate that at, or even describe some of the processes you would use to kind of get to that number?
Yeah, I think we really need to understand some more specifics of your site there, your objectives, type of algae you have, nutrient concentrations if you're looking for more long-term, so versus reactive. So it's a little difficult to give you an exact number here to solve your problem without knowing some more characteristics.
Well, yeah, I wasn't looking for an exact number. I was just, looking for some kind of a ballpark. But if you don't feel at ease giving, that kind of figure out, then I'll try you privately.
Yeah, it's just difficult without, comparing apples to apples, because these two companies could be taking in very different assumptions, and therefore your estimate wouldn't necessarily be accurate. So yeah, why don't we just talk about some of the factors, like what are the cost determining factors in application? Tom, you're on mute.
I think Wes would agree with me. It's timing, intensity of the bloom, the rate you're going to need to get a concentration exposure time with your active. It's copper, you have a little longer time and time for the product to mix in the water, and it's longer availability in the water versus PAA and peroxide. Again, the prophylactic applications of the granular pricing varies based on where you get it. But I could ballpark, let's say it's $120 to $1.30 a pound or so for the granular products. And 100 pounds, that's $130 an acre maybe for that 100 pounds an acre. But that again is just the application of the granular. If you're using 200 pounds, it'd be twice that. It's a decent investment for potentially the benefit of limiting the severity or the onset, and like how late you see that bloom. You likely will still see cyanobacteria, but hopefully it's not as intense, and you can get ahead of it once it's in season is another algicide, a liquid algicide. But that's the kind of the idea of that application. And again, like the phosphorus binders, it's important to treat with an algicide in season to lyse those cells, to release the phosphorus. You can't have live algae and cyanobacteria and put a phosphorus binder in, because it's still going to be inside those cells. You need something to kill the cyanobacteria, and then follow it up and bind it up. That's why a lot of those treatments are done for systems that don't flush in the winter. Usually that's the best time to do that is in the winter, before it blooms. I think everyone would agree.
And you may need to allocate funds toward the applicator, an applicator company to actually put the product out to. There's time and cost investment, permitting, so forth, to actually putting it out. So keep that in mind. There's some additional periphery costs too. So likely.
I want to bring Greg in. Do you have anything to add?
I don't kill anything. So once these two guys, whenever you fight with these two guys about killing it, and then you need to bind up and bind up the phosphorus and get to the root cause of the problem, then you come talk to me.
Such a pacifist, Greg.
All right. Any other questions? Okay. All right. I have a question. This is for everybody. All the presenters today. I mean, what is something you wish your customers knew before talking to you?
I'll go.
Yes,
I'll go.
Oh, go ahead.
I'm a chemist. I wish they knew their chemistry of their body of water. Again, like I said, I'm a lifelong chemist, and like I said, chemistry drives biology. So usually they come to you with a problem and have no idea where they are at the moment and what is driving. They know they have algae, or they know they have HABs. They don't like that. They don't know why or what's underlying driving that. So usually that's what I would like to know, is more about the the chemistry of the body of water and what's driving the problem that they actually see.
Yeah. Greg and you and I have talked about that over a drink and a beer at some of the meetings. Is like, that's a selling point for peroxides often. I talk to people in Florida or places that have hard water and they're banging their head against the wall. They use copper sulfate and they have a really high hardness, high alkaline water, and copper sulfate binds it up. You really lose efficacy quickly in water quality that's not conducive for copper treatments, where peroxides don't have that challenge. So yeah, that's always people are like, oh, I don't know what it is. I'm like, what? And you're talking to an applicator. You're not even talking to a property manager.
Yeah, I'll build on that. The additional thing would be good to understand. Yeah, that the type of algae, the cyanobacteria, the density, where it's at, what makes it tick. Is it colonial? Is it toxin producing? Is it microcystis responds differently than Raphidiopsis to all sorts of things and has different nutrient requirements too. So yeah, aligning the water chemistry with with your issue and realizing that it may change through time. So that's a big ask.
Pond moss. Like, you got pond moss.
Yeah.
All right. Well, great answers, everyone. Last chance for questions. All right. If not, I have some final things to go over. A lady earlier asked about having the slides available. So we do have a YouTube channel, and you can go to YouTube and search the California Lake Management Society. And if you do, this is where we upload our past recordings. And so you can, just usually check back within a day or two after the webinar, and it should be there. And then moving on, we have an exciting announcement for our next webinar. This one is concerning the update to the general permit for the state of California. And so we're pleased to host Gergen Chan, who is the coordinator, and that will be happening Wednesday, April 8th from noon to 1 p.m. So keep an eye out. We'll be sending out some announcements regarding that. But again, please give our hand to all of our sponsors today. It was really informative, and I certainly learned some new stuff. And lastly, have a great rest of your afternoon, and thanks for joining us today.
Thank you again for the opportunity.
Yes, thank you all for everything. Thank you.